All right, so you guys are good to go. You guys can start adding people in.
Okay. Got to figure out how to do that. This is my first time using this.
All right, so you guys are good to go.
Okay.
You guys can start adding people in.
How do we do that?
All right, let me see.
Okay, I see. Okay, can everybody hear me? Turn the volume on. Or down. Okay. Let's see. How many people do we have here so far? If everybody wants to tell us where they're from. You might have to match your space bar to get your sound to be able to work. And I will warn y'all, this is the first time that I have ever used this. So you'll have to, it's going to be a little bit of a learning curve. I've always used Facebook. And if I can figure out how to get the chat thing on, y'all can chat with me also. I just turned it on my wife, so she will be able to see it. It looks like we have 9 here so far. Okay, I've just sent a message out. See if y'all can respond to me. Okay, you can hear me? I could figure out how to get the view to where I can see more people now, because right now I'm only seeing, of course, you may not have your cameras on. Okay. Okay, I've got another camera coming on now. All right, I don't know how many of y'all have ever met me. We have been down to Red Zone and quite a few other places down at Colaqua, and even went to some clubs down further in Florida, teaching a lot of different honors. So I will be teaching 3 different honors today, and I hope y'all enjoy them. You'll probably see us down at Red Zone again, I'm sure, and we're supposed to be down at Southern Union teaching honors. That's kind of what me and my wife do. We're not part of a club anymore. So if y'all need any help with honors at church, you're more than welcome to contact us. I'll have a website on the last slide of this. Y'all can get with us. We're going to actually be down in Naples next weekend doing a Creation Sabbath program. So if any of y'all are close by and would like to come see us, come see us. But I guess we've given enough time for anybody that wanted to come in, and we will keep our eye out. If anybody else wants to show up, we can let them in. But we'll go ahead and get this started. I don't know how many of y'all are interested in geology. I know some people that's not their thing. It is very interesting. I will tell you, I learned a little bit more just recently because we took a trip out to Yellowstone. And if you want to learn about geology, that's a great place to do it. You'll find a lot of stuff out there that shows you how the geology of the earth works. But do all of you have handouts? Has everybody been able to download those and get those? If you happen to need some of this later, get with me and I can email you some of the materials, but I know I sent them ahead, so everyone should have that. And if I happen to lose my internet connection, just type on there and let me know. My wife is watching it. She's using her phone. I'm using our landline, and they're not always the best where we live. We live out in the middle of the woods, but we're going to do our best, and hopefully the Lord will bless us and we'll stay online. I see we just had somebody else check in, so we've got one more here. I seem to have lost everybody's camera feed, but that's fine too. You have more cameras? Okay. Well, hopefully everybody's still got me, but we will go ahead and start with the honor. I hope everybody can see it on your screen fine. Let's see. But the first thing on the geology they go through is the different definitions, and I guess that's a good way to do it because that way, hopefully, once we get past those, everybody will know what we're talking about whenever we use some of them. So let's start with going through that. I know all of you have heard of a delta. Let's see if I can get my screen to change real quick. And it doesn't seem to want to. Naturally, everything works perfect until you start. So let me see if I can pull this up, see why it's not working right. And we'll start this again. There we go. Okay, a delta. What we talk about when we say a delta, and I'll go on to the next slide because it actually gives the definition. A delta is a landform where the mouth of a river flows into an ocean, sea, estuary, or lake. So I don't know if you can see my cursor on the screen. Can you see it, Amy? Okay, my cursor, I'm outlining where the delta is. So basically, you know, the original shoreline would have went somewhere right in here. But as the river flows, naturally it brings sediments, you know, pieces of sand, small rocks and silt and things like that. Well, as the river flows out, it's moving fairly swiftly, but whenever it hits the body of water, it slows down because it just kind of all spreads out. And as the water slows, that allows the sediments to drop out of it. And it actually drops out, and eventually it builds up into a landmass. So that's where the deltas come from. You know, this is a lot of times it happens over a very long period of time, or if you have a large flood event or something, and you have a lot of water moving out and it's moving the sediments very quickly, these can build up fairly fast. So you find a lot of deltas around. I know probably many of you have heard them talk about the Nile Delta and different things like that. I think there's a little bit of a delta coming out of the Mississippi River and different things. So that is what a delta is. Nothing really complicated about it. It's just a naturally occurring geological system that just happens. Like I say, when the water slows down, the sediment drops out and it's going to build up sooner or later. And like I say, when it builds up, it'll end up creating land and it just keeps moving further and further out. And you know, eventually you get a pretty good sized little peninsula coming out there that the delta turns into. Okay, so hopefully everybody can know what a delta is, and maybe you've had enough time to write down on the worksheet what it is. So we will move on to the next one, and that is a cirque. Whenever we were out in Yellowstone, we went through the Beartooth Mountains, and we saw several of these. And the cirque is actually what looks like kind of like a little bit of a round valley or a depression through here. And it is an amphitheater-like valley of a glacial origins. So basically, you know, a lot of this was just kind of crushed out and moved out by the glaciers, and it ended up creating a depression. Because we go into it a little bit more as we go through here, but you know, whenever you're talking about hundreds of thousands of feet of ice sitting up there, that's a lot of weight. And as the ice sits there, if there's any slope at all or whatever, it slowly moves as gravity pulls it downward. And as it's moving, it is scraping off the top layer of rock, sand, or whatever. So the ice can really move a lot of things like that and tear up a lot. And a cirque is just one of the features that you can get from glaciers. There's a lot of different things they can do, and it's real interesting whenever you can actually go out and see them and see the massive scale of the things that have moved and stuff from these different glaciers. All right, so we can move on to a sand spit. And this is one example of a sand spit. So the definition of a sand spit is it is a deposition landform found off of a coast. A spit is a type of a bar, like a sandbar, or a beach that develops where a re-entrant occurs, such as at a cove, bay, ria, river mouth. Spits are formed by movement of sediments along the shore. So, you know, you have a spit like this. I believe these are technically kind of considered spits also. And just from the action of the way the waves and the currents move here, and then you have interactions, you know, whenever you have something like this, if you've ever been in a river and you saw a little cove or something, you'll see like little whirlpools and eddies going on there, and you have all kind of different, you know, types of swirling motions and stuff like that, where the two forces of the water interact together, because this water out in the main body is going to be moving at a different rate than what is up inside these little bays and things like that. So that causes the sand to build up in different ways, and it creates the sand spits. It's just one of the formations that the water will create on some different things like that. Hopefully everybody's got that. Hopefully everybody understands this. If you have something you need me to try to explain a little bit more, or you missed something, just type it in on the chat and we'll try to go over it a little bit more. Or if you need to, just unmute for a minute and ask me a question. It's no problem. I think we're going to have plenty of time to get through this. Okay, move on. And I hope your worksheet's going along with what I have. It should, because I'm going right down on the worksheets that I sent. Now, just a second. Okay, is this a sand spit? And that is this little piece right here to the side. And like I say, even these little thin pieces, and let me go back to the one before, you'll see right here, you see to the side, you've got what looks like a bar out inside, you know, off of the shoreline a little ways. That's a sand spit. And I know down in Florida, trying to remember, I think we were down in Venice or some areas like that, and we saw some sand spits in that area. If you go up off the Carolina coast, you'll see a lot of them, you know, to where you're on the shore and you can look out sometimes 100 feet to a half a mile, and you'll see another sandbar out there off the shore. And that's a type of a sand spit. So I hope that answered your question. If not, we can try to delve into it a little bit more. But like I say, it's just basically a bar that's off the coast, and it's usually where you have a cove or a bay or something like that. And like I say, you've got one force of water kind of in the bay, and you've got another one out in the ocean, and it creates two different currents there, and it's probably where the currents meet that allows the water to kind of slow down or something that allows the sediments to drop out of it, just like with the delta. So, like I say, it just basically most of the things like this out in our water are all caused by currents, and they slow down or something, and it lets it deposit the sediments that it's been carrying. Okay, I hope that answered that. If not, just messages. But okay, a mesa. Um, the mesa is basically something, with a flat top like this. It just kind of sticks out. But also similar to what a lot of people would call a butte. But a mesa is an elevated area of land with a flat top and sides that are usually steep cliffs. So I'll go back to this picture, and you can see this has very, very steep cliffs on the sides all around it. And basically what probably happened is during Noah's flood, the whole area out here was probably at the same level as you see at the top of this mesa. But you probably had a big inland lake or something, and as all that water flowed out, it washed and ripped off the whole top layer of everything around this. But for some reason, this area may have been a little harder, it may have been dried a little quicker, but something allowed this piece of ground right here to stay here. If you go look at the top of the Grand Canyon, there's two of these that are 900 foot tall that they call buttes, and it basically is the same type formation. Now, they believe that above the Grand Canyon rim, there was probably another mile of sediment that has been ripped off, plus the mile going down into the Grand Canyon. So one time there was a very large event that carried away a lot of sediment. And we believe as creationists that it was caused during the Great Flood. Um, you can look at the diagram here on the side, and you can see the different layers of the type of rocks, and you can see where there's some, it says marine origin, which probably means it's full of different marine fossils and things like that. So it's really interesting if you like geology to get into some of this stuff a little bit more. You could look at the different layers of rock, and you can kind of see where they were probably deposited in different places and stuff. And I just believe a lot of this was probably done during the flood. A lot of good proof for all of that. Okay, we'll move on. Now, sinkholes. Sinkholes are something if you live in Florida, especially in the interior, I think around Ocala and even further south than that, you see a lot of sinkholes in that area. Here's a picture of one here. You see a sinkhole so big it's actually swallowing the house up. And I have seen that many times over in those areas. So basically what a sinkhole is a sinkhole is a natural depression or hole in the surface topography caused by the removal of soils or bedrocks, often by water. So basically what happens, you'll get a river or something up underneath there, or it could even be groundwater. And you have usually, like down in Florida, you have a lime rock layer below the sand. And what happens is as you get rain and stuff like that, some of this lime rock is not as strong as others, and you even get some acids in the soils and stuff that will go through there and it will deplete some of that lime rock and kind of eat it out, and you end up with a big hole up underneath there. And basically when you have a hole up underneath there, it can't support what's above it, so it falls in. And then also sometimes you have rock down there that has channels and stuff like that, so it will allow the water to just drain into there and it disappears and it goes somewhere else. Like I say, you'll see a lot of sinkholes in that area. I believe I've got a few more pictures here. I hope all of y'all have got the definition of it. We'll keep going. Here's another pretty large sinkhole. You can see kind of up here at the top, this is a swimming pool. And by looking at the people in the vehicles, you can see this is a good sized sinkhole. And here's another one, right in the middle of the city. Some of these could be man-made also, because if you have large drainage pipes and stuff like that, and they end up getting a hole in them, that allows the groundwater to start going into the pipe. And as the groundwater is going into the pipe, it will carry the sediments and the sands around with it, and you end up with a large hole up underneath the ground, and it'll eventually cave in. But as you can see, this sinkhole here is very scary, as big and deep as it is. I know there have been many times that people have actually been asleep in their house and the house will fall in a sinkhole like this. And sometimes, some of them have not been a walk away. It's actually killed them. There are other times that the people were able to survive and get out of it. And I'm sure it's a very, very serious
Excuse me?
situation.
Can you go back for 1 second to
Think
the
about that. You'd like to say, yes.
Can you go back for 1 second to the definition of sinkhole? I
The
just missed the
definition?
last part. Yes, please.
Sure.
Thank you.
So like I say, the sinkhole is something that's very common in Florida, no problem. And you'll probably see some news stories on them from time to time. Sometimes they don't know why they happen. They kind of figure, but I mean, it's hard to see underground to know what's going on. So you never really know exactly what causes it, but they can theorize pretty good, and they're probably right with what they're talking about, because the lime rock is not as strong as a lot of the other bedrock moray very quickly. Okay, maybe everybody's got that. We'll move on. Okay, alluvial fan. So that is this formation that you see right here. In some ways, I'll move on to the next one with the definition, but in some ways it reminds me of a delta, except for it's not out in the river, it's actually on land. So an alluvial fan is a fan-shaped deposit formed where fast, typically at the exit of a canyon or in a flatter plain. So you can see right here, you had a stream or a river at one time flowing through here, and it was eating down through this. This is probably rock, but it's probably a sandstone type rock or something, so it's going to wear it away. And as it come down there, it's slowly carrying little chunks and pieces off of it. But when it gets down in the valley, it's not going, the water's not moving as fast as it would be on the mountain. So it slows down and allows these sediments to drop out. And, basically, once a bunch of them drop out here and it starts getting high, well, the water wants to move to the lowest area. So it just kind of spreads back and forth and it creates a fan shape. And I don't know where the alluvial come from, but, it looks like a fan. Like I say, it's really the same thing as a delta in a lot of ways, except for it's not forming inside of the water. It's forming up on, flat ground. But you can kind of understand how it's formed. Like I say, the water's going very, very fast, and as it slows down, the sediments drop out of it, and that's what creates it. Okay, hopefully everybody's got that definition. So an oxbow lake. Now this picture I have is not an oxbow lake. This is an oxbow. But I kind of wanted you to see what an oxbow is. Basically, this is a river, and you can see it makes a big bow shape. Now, what creates an oxbow lake is whenever the river washes on these sharp curves right here, and it actually punches through this little landmass. Well, when it does that, it's closer for the river to run straight through, and it no longer runs around the long way. So the river changes its course, and then these two little, I guess you'd call them channels that were originally the river, eventually will seal in because the water's not running through them anymore. So I'll go to the next slide. You can see right here that the water used to run this way, but now it is no longer running that way, and it's sealed it in here and created land. So this is an oxbow lake right here. So an oxbow lake is a type of lake which is formed when a wide meandering stream or river is cut off to form a lake. They are called oxbow lakes due to their distinctive curved shape that results from this process. In Australia, it's called a billy bottom. So as you're looking here, you can see, like I say, we have one oxbow lake here, but eventually you'll probably have another one whenever the channel cuts enough here and gets cut through, you'll have another one over here. And I think I've got one or two more pictures, but we'll hold here for just a minute to make sure everybody gets the definition down and they can have it where they can understand it. But just kind of really a neat feature. I'm sure it takes a while for this to happen. Because usually these are slower rivers, so they're not cutting into the sides of the bank a whole lot. But if you're down in the Amazon or stuff like that, you might have monsoon times to where it gets cutting through a lot worse. It just depends on where you're at. But okay, I'm going to move on to the next one. If y'all need me to go back, just let me know when I look. So here we can see a large aerial view. And I've not tried to count them, but I mean, you can see different areas, and you can kind of see what looks like oxbow lakes all through here. And the way this whole area looks like at one time the rivers just kind of run back and forth over this whole area. And sometimes that happens when you have a flat area. The river will build up a little bit of sediment, and it's going, it'll build it up on one side, and it's going to slowly move to the other side, whichever side's lower, until it builds up there, and it just moves back and forth. Okay, anticline. Not sure if any of y'all know what this is. If any of you have been up in the mountains, you have probably seen rocks like this. You see how all this is just bent and moved? Okay, let's move on to the next one. So when you have something like that, the anticline is kind of the uphill and the high side of it. So an anticline is an upward curving fold with layers that rise from the center of the structure. So it is kind of the upper part whenever you see the rocks that have those lines bent in them like that. And we'll do the syncline in just a minute. But as you can see from the picture, it's the valley. So I'll give you just a minute. Now, something interesting about these rocks, you'll hear evolutionists talk about different things and all this, and they talk about how these rocks were pushed around and moved. But, has anybody ever tried to bend a rock? In most cases, they break. So whenever we look at the rocks and we saw them like we did earlier, where you see all the lines and they're bent like that, that had to have been done while the rock was still soft. I mean, a lot of these rocks are rocks that were, kind of a sedimentary like rock, or even a little bit different. And we know that these rocks had to have been formed probably during all the geological action you had during the flood. And the rock was still soft, as a lot of it was being formed from the forces and the different things that caused the flood. And you had movements of the tectonic plates and all kind of things going on there. And it pushed some of these up and some of them went down. Like I say, this rock about had to be soft at the time, or else it would have just shattered. So another feature we can see that probably happened in the flood. Now, a moraine. This is something else that is caused by a glacier. And we can see some of it here. I'll move on to the definition. But a moraine is any glacially formed accumulation of unconsolidated debris that may be composed of silt, like glacial flour, to large boulders. So you can see that you have a moraine right here down the center of the pathway where the glacier was traveling. You've got another one on the outside edges, and then you have another one down here. So what happened is, as the glacier moved, it's pushing, different sediments and stuff out of the way to one side, like a motor grader would going down the road, leaving a windrow. It's also depositing some of it as it's slowly traveling down there. I mean, it's crushing it up and carrying, but at the same time, it's leaving some too. But then you get right here at the terminal. So basically, this is where the glacier stops. And when it stops, even though there's still more coming, but it's probably melting at this area or something. So since it's still moving, it's acting like a conveyor belt, and it is slowly moving it down and depositing down there, because as it melts, it's dropping out, and there's nothing there to keep carrying it on. So that's what a moraine is. And I'll go back to this other picture real quick. You can see probably a lot of this that is going on in this U shape around it is probably what that is. That's probably where it has been deposited over the years. And probably just because of the way that the temperatures are right now or something, it may have melted back, or it might have not have been as much snowfall. but you get that. And I mean, you can even see on the edges here a little bit of a windrow where it's done. And I mean, the pictures don't really give this justice, but I mean, you're talking about so much weight, it's unimaginable that all this ice and snow weighs, and it will tear hard, solid rock up. It's so heavy and stuff as it's moving. I know you can hit ice and you see it break, but I don't know if any of you have ever messed with any huge chunks of ice, and you can hit them with a sledgehammer and it'll bounce off. Ice is very strong. Okay, we'll go back to syncline. As you can see right here, you have an anticline and the syncline. You can see it goes up here and comes back down here, or I guess it could be the other way if you're coming from this side. But the syncline is on the valley sides, and like I say, you may have seen this going down the roads. It's very interesting and very neat to see, but just remember, this is hard rock. It would be shattered if it tried to move like that right now. So something had to be different in the past for it to be able to do it. So a syncline is a downward curving fold with layers that dip toward the center of the structure. So like I say, basically it's the valley is what it is. It's all downward curving. So you have an anticline and a syncline. And I hope I'm saying those right. I'm not a geologist. I know one. I should have asked him how to say some of this stuff. And I've never been real big into geology, but it is very interesting if you ever get out there and start seeing some of the stuff, and you start talking to somebody that can tell you how we believe it was formed. We were not there. So when evolution starts telling you about how all this stuff was formed and stuff, they were not there either. And just always keep that in mind. Okay, so we're moving on to something a little bit different now. Describe the different types of volcanoes. Now that's something that I guess we did see some of them whenever we were out in Yellowstone, but it would be neat to go out to Hawaii and see some of them that are melting and doing the lava like this. Not that I want to live around them, but it would be neat to see several types of volcanoes. So you have a composite, a cinder cone, and a shield volcano. So let's go into some definitions of some of them. So a shield volcano, or your basic volcano, or cone. So you have a shield volcanoes are enormous features built up only from layers of lava. They produce lots of lava, but they tend not to erupt violently. So these would be, like I show here, Mount Mauna Lea out in Hawaii. And you can see, you know, the lava just slowly comes up and goes over to the side. And it slowly builds up and gets taller and taller over the years. So, you know, it's nothing real violent. I guess in some ways, probably if you saw the eruptions that they had out in Hawaii last year, that would be kind of the basis of a shield type of volcano. Now, I think here in a minute, we see some things to where, you know, you will have some lava tubes and stuff where they can flow out of the side, which is probably what was happening out there. But although, I mean, if you were standing beside it, it was violent, but it was not violent like Mount St. Helens was whenever it blew. Okay, maybe everybody's got that definition, and we will move on. So here's a picture of a shield volcano. I mean, that's a big volcano. There are a lot of them around nowadays. Most of them are not active, and that's probably a good thing for us. Okay, so here's the shield volcano at the bottom we just talked about. And then we go up to the composite volcano. And I think I might even have a different definition. So y'all don't have to write all this, but you can see that sometimes on them you even have a secondary cone and stuff. Let's see if I've got another slide. Okay, well, that might be the definition we needed. A shield or a composite volcano, they're more of a destructive type of a volcano, if you want to put that down. They would be something similar more to like Mount St. Helens. So what happens is, you know, it says right here, When the organic oceanic plates sink and the mantle melts, it forms magma. Magma's mixed. So it comes up through cracks in the earth and erupts at the surface, forming a volcano. Composite volcanoes have steep sides, which is something a lot different than the crater volcano we just saw. So let me move ahead to this picture. If you'll see, this one that I'm bringing up on the screen right now has a lot steeper sides than this one. So that's another characteristic that we have to deal with. So it has a lot steeper sides. Also, the lava is stickier, so it doesn't flow as far, and it's acidic. Because you have the different acidic levels and things like that. Volcanoes can be real interesting to study. But once again, down here at the bottom, if you want to put the composite volcanoes, I guess the definition you can put is they have very steep sides and the eruptions can be very violent. So probably not what you would want to live by. Although, to be honest with you, either one of them wouldn't be all that great to live by. I know my sister lived on the Big Island on Hawaii for a while, and although it's beautiful, they don't call it a fog, they call it a bog. It's similar to like the smog you see out in California. And she says it puts a lot of people in the hospital. And what happens is the gases out of the volcano mix in with the air, and it's very bad on your respiratory system. She said they never tell you that when the tourism boards want you to come to Hawaii. Okay, here's another example of the shield volcano. And here's another example of the composite volcano. Now this one also would be a composite type volcano, and you can see where at one time it had an eruption and blew the side out here. Okay, here's some other things on the volcanoes. And then once again, something to think about is all of these diagrams that you see in the magma chambers and all that. We have not been able to get down there and see all this stuff. All this is theory and speculation. They're probably right. I'm not going to argue with it. But it's something to think about because there is so much unknown in all this. I know when we were out at Yellowstone and looking at the different geysers, I think they said the deepest they'd gotten the camera down in the geysers was only about 250 feet. And they don't really understand the whole plumbing and stuff of how the geysers work out there. To hear them talk, you would think they did because they seem real confident, but whenever it comes right down to it, there's still a lot that they don't know. Okay, hopefully everybody's got everything down the volcanoes, and hopefully you understand them a little bit more than you did. I know we've not went in depth on them as much as would be good. This is just kind of a quick overview on things, and I hope it'll spark you to want to learn a little bit more about geology. So let's talk a little bit about how glaciers move and what evidence it leaves behind. So you can look here and you can see cracks in the snow here. So that tells us something's moving, because if nothing was moving, you just have a pretty blanket of snow like that. So this gives you a little bit of a thing showing how a glacier moves. So basically, it keeps snowing on the side of a mountain like this, and the snow ends up forming into ice sheets. Well, as I said before, that is very, very heavy. So it may not move fast, but eventually gravity is going to slowly pull that ice sheet down to the valley. And as it's going, it is slowly pulling any rocks, boulders. I mean, some of the boulders that we saw when we were in some of the valleys and stuff out in Yellowstone that were moved by different glaciers were the size of houses. So we're not talking little things. I mean, these things can move massive, massive boulders and everything else, which honestly, once it hits the size of a house, I don't know if I would call it a boulder, but they still technically class it as one. But, basically gravity is pulling everything down. And since ice is slippery, you get a little bit of water on it, it allows it to do it. And, one of the evidences we have that things like this happen is, I know some of the boulders we saw that were size of houses out there, I think came from 50 to 60 miles away. the glaciers had picked those boulders up and moved them that far because they could go in and check the rock, and see what type of rock it is, and they could find out where the rock was from. So it was very interesting to think about, that a force of nature could pick something up and move it like that. And it would be very interesting to be able to see something like that. I know we saw one or two glaciers whenever we were up there, and they were not very large. No, they had to be pretty old because in one of them they find grasshoppers frozen, and those grasshoppers are extinct. They don't know when they lived or anything else. So there must have been a lot of grasshoppers that when the flood happened, that you froze and left up in those mountains. So that was kind of interesting to see. Now, if you want to get a little bit of a idea of how you can see on this slide, you can take honey and put it on a board that's uneven or something like that, which I'd hate to. And I mean, the honey is moving a whole lot faster than what the glaciers would move, but it's got a thicker consistency. So you can just kind of see how it moves. And basically, you see how they show the honey moving and it's going up these steep slopes. A glacier will do that, but as the glacier does that, it over time will take that sharp slope right there and it'll make it flat. It'll turn it right down. And that's why you see a lot of the valleys have gentle slopes and stuff as they go down, because the glaciers have actually went in there and made them all good and flat. Okay. If there's not any questions on glaciers, if they are, just stop me. But we'll keep right moving along. So, how are sediments laid down in water? And this is something we've talked about as we've been talking about this, but we are talking about it some more. You can see right here, this kind of gives you an example. The river's probably not flowing very fast now. If you have times of rain, it's probably flowing more. But as the river goes, just guess inertia and things like that, as the water moves, the water wants to move in a straight line, but you have a bank right here that is causing it to curve. So as that water moves along, it's going to carry some of that sediment from the force as it's going along and turning. And since it's got a lot more force pushing it this way and eating into the bank, instead of on the opposite side where that force is not pushing it, it's going to eat into this bank a lot harder. But like I say, at the same time it's carrying the sediments, well, it eats the sediments off of the bank right here where it's turning. But as it goes down this way, the river widens out and it's straighter. So the water spreads out, slows down, and as it does that, it allows the sediments to drop out of it. So you can see you have a channel right here that's being ate out. And then at the same time, you see a big wide area out here to where it's been dropping the sediments out of it. So that's just kind of a little bit of a thing. And this is just showing a little bit more. Now, you wouldn't think that a river like this would put sediments up in here, and it won't. But what happens in the area we live, you don't have it as much because we don't have floods, but you get up in the mountains and stuff where you have snow melts. You'll have a little tiny stream that flows hardly any most of the year, but when all that snow starts melting, it'll overflow its banks, and you will carry the sediment and things like that up on top of the hill. I mean, it could flood 5 or 6 foot higher than the banks sometimes. So it will wash a lot of sediments all over. And then as it dries out, and the river goes back to normal, all that just turns into normal ground and trees and stuff will grow on it. And as long as it's not so fast moving, it tears the trees down. And as long as it's not up there for a long time, the trees can survive no problem. And most of the time, if you go around a creek like that, you would never know that it would come out of its banks like that. I know we were looking at a piece of property one time that's not too far away from us, and nice little river flowing through it, and we went there and were enjoying looking at it. But something was kind of weird. I got to looking and you could see a water line about 2 foot above my head. So I come back and got to looking on Google Earth, and it just so happens this was about a 350 acre piece of property. Google had flown over and took the pictures a time whenever there had been a lot of rain and flood, and that all but about 20 acres of that 350 acres of property was underwater. So you can't always take for granted that the way things are when you're there, how they always are. But let's see, you can see right here another little example. The river is going through, and you can see right here, there's a line to where it's carrying the sediments off. Now, a lot of this, if you'll look to the side here, you'll see a little stream coming out. So the river's not necessarily eroding, but the stream is eroding the bank down into the river. And that brings a plume out here of different sediments. And that river may carry those sediments for a mile. It may carry it for 100 miles before they all drop out. It's according to how swift the river is and how small the sediments are. Okay. So hopefully we got enough about that. Maybe you understand a little bit more how the sediments are laid down. I guess we did talk some about laying down, because it picks them up out of the riverbed. It can lay them down the bank. And it's laid down different ways. Naturally, the larger the sediment is, a pebble is going to fall out of the water and sink to the bottom of the stream quicker than very, very fine silt. A large grain of sand is going to fall out quicker than the silt. So it all matters on what size it is, and we're going to go into that even a little bit further down. Okay, we've talked about some of this. Describe the different type of mountains. So we were talking about the syncline and the anticline. Can you see that in these mountains right here? You've got where the mountains have been folded, and that's why they call them fold mountains. And when you go out and look at these mountains, and you see the sheer size of them and how they've been folded. I mean, look at this mountain here of how crazy this thing has been folded. And like I say, that can't happen when the rock is hard. That has to happen when it's still soft and being formed. It's just kind of amazing when you see that and see all the different patterns that can happen. So one of the type of mountains you have are a fold mountain. And they're saying, it's caused by continental collision. Well, it probably is, but like I say, at the time, the mountains aren't formed in hard rock yet. So that makes a big difference on it. When it's still soft, it can move and be pliable. Okay, you have a fault block mountain. And let's see, fault block mountain is a mountain that you have, say, look at this right here and just kind of project the mountain may have come something like this. But the ground up underneath it moved in two directions. Well, when it did, chunks of the mountain broke and fell straight down to fill the hole in of the dirt moving away up underneath it. So block mountains are created when large areas widely broken up by a fault, creating large vertical displacements. And I think probably an example of this would be Half Dome that you talk about, because just the whole side of the mountain fell off. Basically, it split about in half. And that's stuff we don't see happening today. When you go out and see this type of stuff and you see the sheer size of these mountains, you wonder what in the world it took to move the ground up underneath it enough that half of that mountain fell in a hole. And I guarantee you, whatever it was, it probably made the earthquakes that we see nowadays look tame. I know Miss White says whenever she was talking about the flood that Satan and the evil angels were scared for their lives, that it was so violent, and said that as strong as the ark was built, it would not have withstood it if God hadn't have been there and had his hand over it, protecting it. So when we look at things like this that have happened and know that probably most all of it happened during the flood, it gives us evidence of just how violent it was and how scary it must have been. Okay, you also have a dome-type mountain. So a dome-type mountain is an unusual type of mountain that is formed when molten rock rises up through the crust and pushes up against the rock layer above it. Probably one type of example of this would be Stone Mountain up in Atlanta. I don't know if any of you have ever been up there, but that is something that is very interesting to go. You're going along and most everything is just flat, and then all of a sudden there's just big, huge chunk of granite that's sticking out of the ground. I think the next slide I've got, and I hope everybody's got the the definition. Here's another example of it. I'm trying to remember where this one was. I think this may be the one that is in Australia. I used to know the name of it, but I can't remember what it is right now. But it's another one of those large mountains that just, I mean, right out in the middle of nowhere, you got a big dome of rock like that, and it just really looks out of place. Okay, you have volcanic mountains, and we've talked about those. Let's see. So a volcano is an opening in the Earth's surface or crust, which allows hot, I got a typo there I need to go back and fix, which allows hot molten rock, and there's another one, and ash and gases to escape from deep below the surface. So a volcano is another type mountain. And something that's real neat to look at is there are volcanoes all over the world in places that you don't even think about it, but they don't happen anymore. There's a lot of volcanoes in Yellowstone where we were. They say they have detected ash all the way down to Louisiana from whenever it erupted. And I know if you get down, I think in some of the Caribbean islands, you have volcanic mountains, and you don't never think of a volcano down around there. So it's just real interesting to see where things are all over. Okay, I guess I've already talked about this some, but why does a river or stream bed often keep carving on the outside of the bend? Okay, so basically there is a faster current on the outside of the bend, and the more speed, the more erosion. So the faster water eats the sediment, a lot quicker on the outside of the bend than on the inside of the bend. So basically what it does is as it eats it, the river changes and moves course, and that's why we have the oxbow lakes. Now, in this area here is where it's going to eat the worst out here. But, you can see there's still a little bit of a bend here, so it's still going to eat in this area. And then on the other side, you have a little sharper bend, so it's still going to eat in that area. So sooner or later, it's going to eat this little strip of land in between it, and it's going to change the course of the river. And that's something that all rivers do. I mean, I live on the river, and we see it changing. I mean, over your lifetime, a lot of stuff has changed. Okay. So no different categories of rocks. So does any of y'all know what this rock looks like? This is a type of a lava rock. So let's keep going. Lava. And you've got a lot of different types of lava. You have igneous rock. That's a type of igneous rock lava is. And these are other igneous rocks. Granite, garbo, basalt, rhyolite, obsidian, and how you pronounce it? Scoria. Now, something interesting is rhyolite is it's one of the thicker. Thing about the way it cools, it can turn into obsidian. And obsidian is more of a glass. The Indians used to make arrowheads out of the obsidian. So it's real interesting. I know whenever we were out at Yellowstone, there's a mountain that is 5 square miles, and it is solid obsidian. So it's basically a mountain made out of glass. Real interesting thing to see. That was off limits. You were not able to get any rock from it at all. So I don't have any of that. Although the geologist we went to, I'm supposed to send him some fossils from here, and he's going to send me some obsidian from some different areas out there. So we're going to try to do some trading. I did bring some rhyolite back. We were able to get outside of the park. So I've got a few things like that. Okay, you have metamorphic rock, and they're formed when another type of rock is transformed by great heat and pressure. So some of the different types of rock for that is shale, slate, phyllite, schist, and gneiss. So this is kind of showing how the rock is supposed to morph all the way from shale down to the gneiss. Now, once again, We have not seen this happen. This is all speculation. But it may be how it happened. It probably did. But some of these processes, they're really guessing on just how everything was formed and stuff, because this is not something you can test in a lab. And it's not something that we know for sure. But it is very interesting seeing how things can change and turn into different things. Okay, marble is a type of a metamorphic rock, and this is a marble mine. So if you've ever seen marble countertops or marble out in like a headstone in a cemetery or something like that, this is the type of area it comes from. Okay, here's another nice. This is kind of a pretty rock because it's got the folded strata in it. And like I say, it's another metamorphic rock. They believe it was formed at high temperatures. And the reason they say that is because if you try to bend the rock, it'll break. So it would about to had to have been bent while it was being formed. But it is very pretty. Okay, sedimentary rocks. And they're formed when sediments are carried by wind and water. They settle and they slowly turn to stone. Some of the examples of that are shale, sandstone, limestone, conglomerate, which is just, all kind of different sized rocks and sand and stuff that get compressed together, almost like concrete, and turn into a rock. Dark rose, pink colored, and gypsum. I used to have some gypsum out here. It came from Utah. Something interesting in sedimentary rocks that I had never thought of until I read it. You can tell a lot of times if a sedimentary rock was created at creation or created during the flood. And I'll tell you kind of how you can kind of look at that and think about it. During creation, when the land masses rose up out of the water, you had a lot of erosion, and that carried the sediments off. Well, that created sandstone. But when that happened on that particular day, there were no animals and you had no death. So there are no fossils in the sandstone that was created at creation. But now the sandstone that was created during the flood, you will always have fossils because there was a lot of life. And I mean, it can be anything from just plants, small creatures, sea creatures, everything else. But you will usually always find life in sedimentary rock created at the flood. So that's kind of something interesting that I'd never thought about, that sedimentary rock was created at creation. Like I say, as the land rose up, you would have had a lot of erosion as the water, slowly receded off of it. Probably fast in some areas too. Okay. So hopefully y'all are getting all these definitions as we're going. Let's see. So they're wanting you to take a picture or make a sketch of each of the following geological features. So y'all can do that. I know that they are supposed to put this PowerPoint presentation and my talk on YouTube later on. So if y'all need to go back and watch it, you should be able to. So we'll do this. Y'all can, if you've got paper, draw this out real quick, or it's something that you can even take notes and you can look it up on YouTube or something and see how it is and draw it out later. So a bed of sediment that is coarser on the bottom and finer toward the top. That's one of the things they want you to draw out. I said this is called normal graded bedding. So think about it for a minute. Why would you have larger sediments on the bottom and finer sediments at the top? And that's something we talked about a while ago. As the water slows, the larger stuff is going to drop out quicker. And the finer stuff is going to end up staying suspended longer. So you'll still have some smaller stuff, mixed in, but not as much. That's why you're going to have a lot of the larger stuff on the bottom because it falls out quicker. And I mean, that's something, if you wanted to experiment with this, you could take a glass of water, you could put a few rocks in it, you could take a put some sand in it, and then you can put some silt in it, put your hand over the top of it and shake it up, and you'll see it all. And the silt may take hours or days, according to what it is, to finally settle down and for the water to be clear again. But the rocks and the sand will usually go quick. That's one reason, like I live up in the edge of Georgia, I'm right on the coast. Our rivers are full of silt, and they are very murky and muddy, and when it rains bad, they look almost like chocolate milk. So our beaches have a lot of that same silty material in them, and they're not pretty and clear. But if you get down into South Florida, you don't have as much silt and you have more sand. The sand falls out of the water very, very quickly. So even though the beaches come in and the waves crash and it picks the sand up, it falls right back out of it. And y'all have some of the most beautiful beaches down there to us because the water is just clear because you don't have the silt that stays suspended. So when you go out and watch the waves, you can see it move the sand up, but it falls right back out quick, and that's the same type of action we're talking about here. Okay, hopefully y'all, if y'all were going to draw the picture, hopefully y'all got that. So let's move on. Here's another picture you can see of what a graded bed would look like, and you can see you have larger material on the bottom, and it gets finer as you go up until you get to this point. You really don't have hardly any rocks left in it, and it's all just silt and sediment. Okay, here's some other things. And like we said, the grain size is what usually is variable, and that's what changes what the bed looks like. You can have some, you're gonna have some stuff, because like I said, it's the patterns of increased size, average size. You can have reverse graded bedding, but normal graded bedding is what we would talk about, and that's more of what you would find here and here. Okay, ripple marks in sand. I'm sure all of you that have been to the beach have seen this. It's something that anytime you have water like this, you're gonna have this. And they want you to draw a picture of it. Let's see if I've got any. Okay, now something to look at that's different. You notice on these that were formed underwater have a different angle than stuff that you see. Little sand dunes and large sand dunes that occur underwater have a different angle than sand dunes that occur above ground. Let's see, I don't remember how many of these slides this is the last one. When we were out of the Grand Canyon, the evolutionists have always said that the sand in the Grand Canyon was deposited over millions and billions of years by wind erosion. They have now found out that the sand that was deposited, because you can see the angle of the dunes and the walls of the Grand Canyon, and now that they know that a water dune has a different angle than a sand dune that is put up by wind, they have discovered that the sand that was deposited in the Grand Canyon was deposited by water. So that proves, it was put there during a flood event like Noah's flood. And it's really interesting. They finally admitted that most all fossils were deposited in floods, but evolutionists say it could not have been Noah's flood because there couldn't have been a worldwide flood. Although recently, one of them did say that they have discovered there is enough water on Earth that it can cover all of Earth. So they're starting to admit that there could have been a worldwide flood, but even if they admit it, I'm sure they'll tell you that God wasn't the cause of it because they don't want God to get any credit for anything. Okay, so the next thing that we're looking at is gully erosion. So I don't know about y'all, but I know we had some areas it was not this bad when I was small, but it was fun to play in the gullies in some of the areas where I was in. But this is a small gully. I guess Grand Canyon would be a large gully, although I guess when they get that size, they do call them canyons. But I mean, this is a gully. Let's see, you can see a little bit more of the gully erosion. I mean, basically, you have, this is soft material, this is sandy material. And you get a low area, you get a lot of water come through it. And since it's sand, there's not anything to hold it together like rock, and it can wash it out very, very easy. If any of you ever get the chance to go over close to Columbus, Georgia, there's a place called Providence Canyon. They call it the Little Grand Canyon. And I'm trying to remember, I think it's over 100 foot deep in a lot of areas. And one thing that's neat over there is you have a lot of different color sands in the walls. It's very pretty. But a couple of 100 years ago, that was not there. And they said what happened is whenever agriculture started over in that area and the farmers stripped off all of the land and plowed gardens and stuff, they didn't really pay a whole lot of attention to where they were stripping it off and what was going to happen. And they had a lot of bad erosion, and it cut that gully out that has turned into what they call that canyon. And like I say, I think it's a couple of 100 foot deep, if I remember right, and hundreds of feet wide. And all that is from them stripping the vegetation off the top and allowing it to erode. So very interesting to look at. I say there are a lot of things that just in nature that is really interesting to watch. Okay, mud cracks. I'm sure if any of y'all have saw a mud puddle that has been dried up, you notice mud cracks. I don't know how much y'all have those when you get down into South Florida, because what you're seeing here is a silty type material. We have some of them up here. You get on up to where you have clay and stuff in Georgia, you have even more of it because you have the clay and it has more silt in it. But basically you get a layer that's finer silt. And what happens is as it dries up, the water leaves it and it kind of shrinks. And when it shrinks, you have cracks because it's taking up less room and you have airspace now in between it. And really interesting sometimes. I know you can get it that's flipped up like this and it crunches up underneath your feet whenever it dries up. Always been something interesting to see to me. But it's usually more of a type mud puddle. You would get a type of mud that is a very slick mud. Like I say, if you have a sandy type area, you're not going to get anything like this. So more of a silty type, clay type area is where you're going to find the mud cracks. Okay. And then they want us to talk about soil profiles and for you to draw the sketch of it. So soil profiles along the stream bank or a road cut. So you should be able to find how soil usually becomes lighter colored downward from the surface of the ground. Now, what would cause it to be darker up at the top? Be better if we was in a classroom environment and people could talk and stuff, but the reason you have darker soil up at the top normally is you have your topsoils. And what has happened is over hundreds and thousands of years up here at the top, get my cursor up here, you have vegetation that is growing, but it's also dying. You have leaves fall in the winter and then fall, and whenever all this gets here, it rots. Well, as it rots, it creates soil that is very rich in organic material. And most of the time, that creates a darker, blacker material from all the stuff decomposing. And, some of it gets washed down into the upper layer. Sometimes this layer in between the darker and the lighter is thinner than others. It's according to what kind of soil you have. But then, once you get down very far, you start getting into the soils that's deep enough that you've not had any of this happen. So you get into a lighter soil. I know out here where we live on a sand hill, and we don't have much topsoil at all, and it's a lighter, sandier topsoil. But if you go a little bit inland from where we are, where our topsoil is only an inch or two thick, some of those wetter areas, it can be a couple of feet thick. And a lot of that is because some of those areas are lower, and as it rains, it washes that silty stuff down in those lower areas and it builds up more. So there's a lot of geological forces that are happening, and they make the different things. I mean, we're right here on the river, so a lot of our silty type material can wash right straight out to the river instead of staying into the soils. And like I say, our soil is more of a sandy soil, so it doesn't lock in that organic material quite as well. I guess eventually it would get that way, but also too, when you have the lower soils and even more clay in the soils, it stays more wetter and it allows the stuff to biodegrade better and creates a lot more of a higher quality topsoil. Okay, and this is, you can see right here, here's another one. If you want to take a picture, if you've got a ditch with a side like this, this is going to show you right, right up here, you can see you have the darker material, and further down, the lighter it gets. So if you had where somebody's just dug a canal or something like that, and you've not had grass planted on it or something yet, or a ditch that has some erosion, or even a riverbank that has some erosion like this, it's a good place to look at this. Some of the riverbanks around here are very interesting. And some of the riverbanks around here where we had Indians, I mean, they would bury their trash and stuff sometimes. And when the river erodes over to that point, you'll start seeing it coming out of the side of the river. So it's kind of interesting. Okay, sandbar. Well, we've talked about sand spits and stuff like that, and they're almost the same thing. I know here we have a lot of sandbars in the river. This is similar to what a sand spit would be, but it's kind of also a bar too. So it's where the sand has come up and created a high point in that water. So I say there's not really wanting definitions on a lot of this. They just want you to make a sketch of it, or they want you to, know what they are. Take a picture of it. And like I say, if you go to the beach, y'all may have some areas around where you're at. And like I say, earlier, you look at the water here, you can actually see the bottom of it, how pretty it is. You don't get that in the beaches up here where we're at. You normally won't never see the bottom of it. If you do, it's not much and it's not for long. I mean, the water can't be very deep at all. I know the rivers like we live in, you would be doing good to see 6 inches in front of you on a good day if you were diving. So I think we've covered everything. And I see I just got a reminder that we have about 20 minutes left. So does anybody have any questions? You're welcome to unmute and we'll talk about some things if y'all do. As I'd said, we do have a website if y'all ever need to get in touch with us, because we teach a lot of other honors. If y'all ever have questions or need anything, let us know. We're more than happy to help. So has anybody ever been to Yellowstone or any of the areas like that where you see a lot of those geological features in the different parts like that? We may have lost everybody. Well, I hope y'all have enjoyed this. I did see they've got a new honor. I have not looked at the requirements yet, but if you like geology, it's called geological geocaching. And I got to figure out what that is. I guess somehow it mixes the two of them. I don't know if any of you have ever taken the geocaching honor. That's one of the honors we do teach. But that's a lot of fun to go out there and try to find the different caches all over, and a lot of the state parks, they've got them hidden in pretty places. So teach you where you're seeing some areas that you're not normally able to go out and see. So if everybody wants to just type in and tell us where you're from, we're kind of interested. Me and my wife, like I said, we live in Southeast Georgia. We're right on the coast. We're just above Jacksonville, Florida, so we're not far from Florida. We actually met in a church in Jacksonville, and that's where we got married. But we've been living here for a long time, and we're close enough to Florida. We come down and help a lot when people want us to. And like I say, we'll be in Naples next weekend. If anybody's down in that area, I think at the North Naples Church is where we're going to be. All right, well, I'm glad everybody was here. I hope everybody enjoyed it. And I guess at this point, we're going to go ahead and sign off. And if any of y'all want to come back for the next one I believe is going to be on the sanctuary, and we will have it then. We will talk to you later. Like I say, if anybody needs us, y'all are more than welcome to contact us. See, I just had somebody come up. As I said, we're getting ready to go ahead and shut it down. But hope y'all enjoy it. If you see us sometime, come up and talk to us. We'll be happy to talk to you. Like I say, we'll be down at Southern Union. We'll be at Red Zone. But y'all have a good day, and God bless, and have a good Sabbath.